Our first question says identify the domain range intercept of the function. Describe it below. So you can go to Desmos and you can take you can graph it and take a look at the graph. They might have a picture of the graph for you on the test, they might not. Times 4 to the x. So we got our little L-shaped. I don't know what's happening. We've got our L-shaped graph. I guess I gotta type it in again. Take a look at our y-intercept while we're here. Take a look at just kind of the overall shape of the graph. That way we can go back and answer our questions. The domain of the function is all real numbers. So you can do this double bar R, or you can say all real numbers. It goes forever to the left and forever to the right. The range, our graph looks something like this. We'll just use this as a little. Our range only goes as low as this value right here. So our range is 0 to infinity, or y values that are greater than 0. The y-intercept, we took a look at it before we left Desmos. It was at 0, 9. So I would say the y-intercept is 9. The asymptote is like the invisible barrier that the graph will never cross, which we see going along the horizontal axis. So that line, the x-axis, is also the line y equals 0. Y equals 0. We know that vertical lines are always x equals, and horizontal lines are always y equals. In behavior, as x approaches negative infinity, or as we travel to the left on the graph, f of x or y approaches what? So as I look at my graph and I travel to the left, my y values are just getting closer and closer to 0. As it approaches positive infinity, or means as it's moving to the right, my values get bigger and bigger and bigger and go up to positive infinity. No.
What?
Just sit here, you're fine. Determine whether the function represents exponential growth or decay. Write the base in terms of the rate, growth or decay. Identify R. Interpret the rate of growth or the rate of decay. So I know this is in the form A times B to the x, where if B is a number that is greater than 1, it is growth. 4.3 is greater than 1, so this is growth. Rewriting the base in terms of the base rate of growth, we know that B is 1 plus R because we already identified that it's growth.
Wow.
So if I know that 4.3 is 1 plus R, if I want to know what the rate is, I subtract 1 on both sides, meaning that my R value is 3.3. So this function R is 3.3, but that means my function would still be my starting value times 1 plus 3.3. Which indicates the value of y. I don't know what the drop down options for y are. Oh, that it increases by how many percent? Remember, this is the rate as a decimal, so multiply it by 100 for the percent, and you get 330%.
Wow.
I'm too busy trying to test right now.
I can just go down.
The rabbit population of Springfield, Ohio was 168,000. In 2014, it is expected to decrease.
No.
It is expected, can we please stop talking, to decrease by 6.8% per year. Use an exponential decay function to approximate the population in 2034. to the nearest 100. Enter your answer in the box. So we have a times b to the x. A is our starting value. So in this equation, 168,000. It is going to decrease, sorry. So 1 minus my rate as a decimal. So I want to divide by 100 to get my rate as a decimal, 0.068. And then my exponent x is time. How much time passes from 2014 to 2034? That is 20 years. So I typed that all in on my calculator. I'm going to do it on this one to save a little time. And that gives us 41,079.72. And then there's a 5 that says round to the nearest 100. So if there's a 5, that means round this to up to a 3. So my answer would be 41,079.73. Sorry, there were too many 7s in there. I got my 0 messed up. Number 8 for the function 1/4 times 2 to the x. Identify the domain, range, x-intercept, and asymptote. Use the drop-down menus to show your answer. So we know, based on our information of our equation, we know that this exponential graph is going to look something like this. That's our general shape of it. We see there's no shift, so there's no left, right, up, or down. So we know our asymptote is going to stay at y equals 0. My x-intercept is the a term. So a is your y-intercept term, meaning my y-intercept is 0, 1/4, or 0.25, the same thing. My domain is still all real numbers, or negative infinity to infinity. And then our range is 0 to infinity, or y is greater than 0. And we know all of that just from the way it looks. Number 9 we have to do in Desmos, okay? What's up? Yeah. Number 9 we have to do in Desmos, so I'm going to write down the buttons on here, that way they get screen recorded. So you're going to go to Desmos. You are going to hit the plus sign, and you're going to add a table. And in that table, you're going to put your coordinates, 11 and 170, and 12 and 270. And then we're going to type the equation y1 equals a times b to the x1. So I'll do that in 1 second. So Desmos, hit the plus sign, add a table, 11 and 170, and 12 and 270. And then y, I just press the number 1, it goes into the bottom. I do my little squiggly instead of my equal. A times b to the x1. And then that gives me my answers. A is 1.1 or is 1.04 and B is 1.5. I don't know what the X around them to. It was 1.04 and 1.5, something along those lines. It'll tell you what to round to on the Number 10, Sally invests $1,500 in an account that earns 3.4 annual interest, compounded continuously. What's the value of the account after 10 years? That means we need our A-PERT formula. Whenever we see continuously, that means we want our A-PERT formula. So we don't know what the final amount will be. We know our principal amount. E is a number, not a variable. And the exponent is rate times time. I want to divide this by 100 to get a decimal. That gives me 0.034. And then how much will be in the account after 10 years? Times 10. Then I would just type that in a calculator. $1,500. E, remember, is second divide. There's a little E above it in blue. Second divide, and the exponent, 0.034 times 10. And that leaves us with $2,107.42. So in multiple choice, 2,107 was our answer. Number 11, Micah invests $3,280 in account, earns 3.2 compounded monthly. Write a function for the amount after 12 years. That is not the A-PERT because it's not continuous. So that's principal value times 1 plus the rate over n times the rate times time. And for this specific example, we get 3,280 times 1 plus 0.032. And if I'm compounding monthly, what is my n? How many times does monthly occur per year? 12. Very good. There's 12 months in a year. So anywhere I see 12. And it says how much will be in the account after T years. And so it's fill in the blank. So A equals, my first thing is my initial value times 1 plus 0.032 over 12 to the 12t.
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 This might need C.
Sydney not coming back?
What was that?
Sydney? She's been back there.
She ain't coming back.
Write the inverse of the exponential function. So the first thing that we're going to do is we are going to switch x and y. So x equals 5 to the y. I'm going to do the little half step where I move the y to the left. Because I'm better at going to logs like that, but of course you can just leave it the same. Think of your 3 positions of the x. The base stays the base, and the other 2 numbers switch. And then I'm not sure what it's looking for because this says x. So if it's looking for x, then our answer would be 5y. But if it's looking for y, just be cognizant of that on the test. Then it's looking for log base 5 of x. So I'm not sure which one of these it's looking for. I don't know if this is a typo. If it's not a typo, then this is the answer. If it's not, then this would be your answer. Number 13, write in exponential form. You can do the half step where you move the log to the left. Maybe you're comfortable with it on the right. Do whatever you want to do. But the base stays the base, and the other 2 numbers switch. So 3 to the negative 3 equals 1 over 27. Obviously, typing these in on Canvas is always harder than typing them in on Envision. Because Envision will let you put something in the exponent, will let you use the symbol button to get a fraction. It's a little trickier to type in Canvas, so don't be stressed if it doesn't give you the right answer. Which of the following have been evaluated correctly? Select all that apply. So, yeah. Kayla, will you open my thing and I guess? You don't need to.
Well, what the? I just gotta go to this why to do some work.
You said you were with her all morning.
And I've been doing work. That's what I'm saying.
She said, you said you was with her all morning. Thank you.
I can't get no pass.
No. So this is asking, is e to the 0 1? That is correct. You guys can check these by typing them in on your calculator and seeing if they answer correctly. This one is asking, is 2 to the 3rd 8? That is true. That is also correct. Remember, when you don't see a base, that means you secretly have base 10. So this is asking, is 10 to the 1/2 1 over 100? And that is not correct. This one is asking, is 3 to the 1/3 -1? That is not correct. This one is asking, is 5 to the -3 1 over 125? And that is correct. I just know those because I know a lot of exponents, but of course you guys can just type those on your calculator and see if it does correctly answer the question. Write the log in exponential form. My base stays the base, and my other two numbers switch. 2 to the 4 equals 16. Cedric, can you please stop rolling the die? Cedric, I'm gonna take them if you don't. The altitude A in feet of a plane T minutes after takeoff is given by this function. Solve for T in terms of A. And then there's a follow-up question that we'll answer in 17. So we have to find the inverse of this function. We have to get T by itself. So it looks a little tricky, but it's a lot of this algebra 1 with big numbers. I have A equals 9,000. I'm just rewriting my equation so that I can start doing. If I want to get T by itself, the first thing that I'm going to do is I'm going to subtract 4,000 on both sides. And since A is not a like term with 4,000, there's nothing I can do other than just subtract it to the side. The next thing I want to do is I want to divide both sides by 9,000. And again, since I don't know what A is, that is the cleanest way I can write it. A minus 4,000 over 9,000 equals ln of 0.2 t. So now I have to rewrite my exponent as a log, or sorry, my log as an exponent. I'm going to do the little half step where I put my log on the left. And I know that natural log is log base e. So I know my base is going to be e. And then these two things are going to switch. My exponent is going to be a minus 4,000 over 9,000 equals 0.2 t. And then I divide all of that by 0.2. So if we look at this equation, t equals e I don't know what all the boxes are for. I don't think it'll be like this on the test. But we have, what's up?
Be careful writing on the side because you can't really see it.
Gotcha. So we've got, I think it's 1 times e to the a minus 4,000 over 9,000 divided by 0.2. Hey girl. And then number 17 says the equation above, what would be easier to use this equation instead of the original one? All of this, I love you because all of this would be easier if we had known what A was. Because then we could have done real math and known these numbers. So it would have been easier when the altitude or when A is known. Otherwise, it would be easier to use the original function. Find the average rate of change of the function graphed right here compared to the average rate of change of the function 6 log x plus 20. The average rate of change is just slope. So if we remember slope from geometry, we have x1 and y1 and x2 and y2. So it's 27.9 minus 23 over 50 minus 10. So that gives me 4.9 over 40. And then if I simplify that in a calculator, that gives me 0.12. And so now we want to figure out what that number is for the same interval. So I want to take this equation and I want to plug in 10 and see what my y would be, and I want to plug in 50 and see what my y would be and do the same slope again. So in my calculator, 6 log of 10 plus what is it? Can you guys tell me? It's 6 log x plus what?
Plus 20.
Plus 20. So we get 26 and then 6 log of 50 plus 20. And we get 30.19. So the y minus the y would be our answer minus 26. We get 4.19 over 50 minus 10, which is 40. So we get 0.10. So we get 0.12 versus 0.10. And so the graph is greater than the rate of change of the given function. 19, the log function is translated. We know a plus 3 on the inside means left 3. We know a plus 1 on the outside means up 1. So select what's true. That's not true. Up 1 is true. 3 to the right, that's not true. 1 to the left, that's not true.
Maybe we can drink water.
What's the equation of the inverse? So we want to do all of our steps. So the first one is y equals, so rewrite the x as a y. And then I like to put, or you can switch the x and y first and then switch the log or whatever. But you can switch the x and y's. And then you can do the half step or you can move the logs to the left if you prefer that.
I go to water.
No.
Why?
Can't you just sit there for 10 seconds? Like,
I've been sitting there for 10 seconds. What are
no,
you talking
but why
about?
can't you just stay in the room for half? Like, why can't I just not worry about you while I'm trying to worry about this?
I just asked you, let him go get to the bathroom so I can go.
Yes, I know, but he's a senior, he's not in this class.
Okay,
You're my
well,
responsibility.
My grade's good enough so I can go.
So then, look at your three positions of a log.
But you see me say for something, I'm not like, I'm going to get
2 to the y equals 8x. Oh, sorry, I forgot to keep those switched. 2 to the x equals 8y. And then we want to divide both sides by 8, which is the same thing as multiplying by 1/8. So that gives us 1/8 times 2 to the x. Can you guys please be quiet? 21, all of these are y1, y2, graph them in Desmos, find the solution. Except number 21, they do have the same base. So you can find them a lot easier. And just set their exponents equal to one another. And do the algebra 1. You, of course, can graph these on Desmos if you are not confident with your abilities. I'm going to add 9x to 8 both sides because I don't like when it becomes negative. Add 12 to both sides. 26 equals 13x. Divide by 13 and x equals 2. Just for time's sake, I'll come back to these because these ones are really easy. I just want to get the other ones in for sure. And then if there's enough time, we'll go back to them. If not, I'm confident all of you guys can type this into Desmos, this into Desmos, and use Desmos to find where they intersect. It says solve the equation by graphing, so same thing. Everything on the left goes in one side, everything on the right goes in the other. Find the correct solution and match it to the right graph. I didn't do all the multiple choice answers on that one in my screenshot. And then same thing, graph, and then select all the places where they intersect. I just want to make sure I get to this geometric solutions one. So choose the correct explicit formula for n. If I know my first term is 80 and my r is 0.5, I'm looking for an equals 80 times 0.5 to the n minus 1. So I have that twice. I know these are wrong and that's wrong. And then this one says for n that are greater than 1 and equal to 1, or just n greater than 1. If you choose this one, that's going to skip the first term. And we don't want that. We want it to include 1 so that it starts at the first term. So A and B were technically correct, but we want to have that equal sign so that we include the first term. So if I want to generate the first 5 terms, I'm going to plug in 1 for the first term, and then after about the second term, you kind of figure out the pattern. So if I plug in 1, I get 80 times 0.5 to the 1 minus 1, which gives me 80. And then if I have 80 times 0.5 to the 2 minus 1, which is 40. And then I can see that it's decreasing by a half each time, so 20, and then 10, and then 5. And I can do that without a calculator because I know that I'm starting at 80 and I'm decreasing by 0.5 each time. Write the series in sigma notation and then write the sum. So n, they want us to add up to, we've got to figure out what that term is. A, we know is our first term is 9. I think this B is supposed to be this C. I think that's a typo. So the C should be 4 because it's multiplying by 4 each time. And then we have to figure out what they want us to add the sum up to. So they give us this final term, and we have to figure out what term that is. So 36,864 equals 9 times 4 to the n minus 1. So I want to divide both sides by 9. And that gives me 4,096 equals 4 to the n minus 1. And then you're going to want to put this into log form. So the base of the exponent stays the base of the log. The other two terms switch. So if the n minus 1 was with the 4 before, it won't be this time. And if I want to solve for n, I add 1 to both sides. And that gives me log base 4 of 4,096 plus 1 is 7. So they want us to add up the first 7 terms, and then we just type this in on a calculator. And we go from 1 to 7 of 9 times 4 to the x minus 1, and it adds up to 49,149.
Is it bad that I still be struggling to say numbers? Because when I be going to go get my oil change, they be like, read the numbers for me. I'm like, 1, 2, 5, 7. Yeah, no.
Yeah. 28, the recursive definition is given below for a sequence. I'm assuming you're just, I feel like that's not a good sentence, but you're choosing the one that's the correct explicit form. So I know our first term is going to be 64, and that we're multiplying by 1/2 each time. And so 64 times 1/2 each time. And then the last one, number 29, is like the one that we just did. This term right here, they want us to know how many terms are in the sequence. So 3,863,116.8 equals our first term times the common ratio. If you can't tell what the common ratio is, work backwards and divide. So do 13.8 divided by 2.3, and you get 6. To the x minus 1 or the n minus 1, whatever you prefer. And then we're going to do it just like we did in the last example. Divide by 2.3. And you get 1,679,616 equals 6 to the x minus 1. Rewrite it as a log. The base of the exponent stays the base of the log. These two switch. So we get 6, log base 6 of 1679,616 equals x minus 1. Add 1 to both sides. I'll do this one on the calculator if you want to see it. But remember, math, arrow up, and hit log base. You want log base 6 of 1,679,616, and then add 1, and your answer is 9.
Ooh,
Your answer.
wow.
And then if you'll click the extension right there, that looks like it's got like a recording button, and you can hit stop. All right, I know this